All right, so this is my section of the presentation for the virtual aquarium, XR Aquarium project with Sanvi, Yayun, and Niraja. I'm going to be going over the rendering architecture and implementation of Boyd swarming algorithms and some of the approaches that I used to make that performant and fast enough to use in VR, as well as some of the basic building blocks of augmented reality that we used to actually make Boids appear in your 3D space around you with pass-through. Basically creating the effect of having schools of fish swimming around your room. So what we're looking at here is a UML diagram. The primary point of complexities or points of complexity are the swarm manager and the compute shader here. Starting with the swarm manager, that's just a C-sharp script that Unity uses to basically manage all of the information about each Boid and the swarm that it belongs to. A swarm is just a collection of Boids that have the same parameters for how to define their movement. As was probably mentioned at some point in this presentation, Boids basically adhere to three main parameters called separation, cohesion, and alignment. You'll see that mentioned down here in swarm data. And each swarm is going to have these parameters defined, and they're basically just going to tell the Boid how close it can get to other Boids, how much it should want to stick with other Boids in terms of what direction are other Boids going. Do I want to go that direction? That's alignment. And then we also have separation, which is just how maybe I'm too close, right? Maybe I want to get a little bit further away. And by combining these three parameters, you can calculate, if you know where all your other neighbors are, what way you should move if you're a Boid. And because of this, we're able to kind of exploit the fact that when you calculate the movement of one Boid, you're really only, it doesn't depend on the movements of any others. It's just you're looking at where everything else is in that moment of time. And by doing that, if we have 1,000 Boids, one really fast way of doing that calculation is to send it over to the GPU so that its cores can do those calculations for each Boid rather than having one CPU core kind of iterate over all 1,000. And as a result, we're able to get really high numbers of Boids, up to, 10,000 even would probably work. I haven't done comprehensive performance testing, but in the demo that you're going to see today, there's 1,000 of one type, I believe 10 of another more predatory type, and then one or two of another predator type. And you'll see those made distinct by different colors. And we'll be talking about that in the demonstration. But suffice to say, this compute shader touches basically every aspect of the simulation. This is kind of where the bulk of the actual mathematics is occurring for the simulation, whereas the swarm manager is really just moving all the buffers around into the right place where the compute shader expects them to be. And that includes, we do have one more shader here, which is smaller and less complex, certainly, but extremely important. This is an instant shader, which just means that, like I said earlier, there are certain kind of tricks you can do with the GPU where if you want to do a certain thing over and over again, you can do that very quickly. And in this case, what we're doing over and over again is rendering the same mesh. So this is how we display lots of different fish on the screen at the same time without losing a lot of performance as well. So kind of without further ado, I think I've been talking about this for about 5 minutes, which is probably the right amount of time. So if we move on to taking a look at the actual demonstration here. For those unfamiliar with the Unity editor, you've got kind of your scene over here on the left that defines everything we have. I'm not going to be talking about the camera rig and the pass-through layer, and a lot of this is related to the VR platform and their API. But the Boid manager is where the swarm manager lives, and that's where you can see that we have a few different swarms defined here with all sorts of parameters. And there's also the ability to basically spawn something that all the Boids are attracted to, which is just food. We're calling it food, but it's really just a place where they're all kind of jump to. But without further ado, I'm going to use the MetaQuest simulator because the Quest doesn't really support capturing pass-through in a simple way due to privacy reasons. They don't give you direct access to the camera footage. So we're just going to use the simulator, which will basically, you'll see it'll simulate the room being scanned. It'll simulate the camera feed. It basically just simulates every aspect of what you would be using in the augmented reality context. And in fairness, I have tested this on the headset as well. It's just not something that I can record. So here we go. There are our Boids. They have all spawned in one place, but you can already see they are starting to flock around. And you can also see that they have an awareness of their environment. They're basically kind of bouncing around off of the different furniture and flowing nicely. And let me just kind of back up so hopefully you can get like a good wide view of them. You notice it's not perfect, but they do tend to avoid the obstacles right now. There's sort of a fine balancing point. You can see some of them jitter out because I think the boundary avoidance is too strongly weighted in certain circumstances, and they kind of go back and forth. So there's definitely tuning to be done here to make the effect a bit more fluid, but I would say overall it's extremely convincing in terms of the frame rates where it needs to be. I maintain 70 to 90 frames per second on the headset and in the simulation. I think we could easily up these numbers of entities as well, or just, obviously there's a lot of room for increasing the visual fidelity of the models. But you can see that, this sort of 3D geometric representation, that's what we're leveraging for our obstacle avoidance for each of these. So they're basically just sending out a raycast. How far away is that raycast? They send that, and if it intersects with a boundary or a triangle that you see here, it's going to do a check, see if it's close enough, and then we're going to basically adjust our trajectory away from that. We're going to steer the Boid ever so slightly away from that, and then we're going to do that basically every frame, so like 30, 60, 70 times a second. And we're going to, the effect of that is that the Boids tend to, adjust away from their obstacles. So I think this is a really cool project. I had a really good time implementing the 3D side of things. I learned a ton about using the MetaQuest 3 and how to integrate their API and all the different samples that they have into, a creative project. And it's very, very satisfying to watch these things kind of run around my apartment. And I think that there's some really interesting potential here in the future for hopefully other simulations that start to inhabit the XR space. So yeah, without any further ado, that's kind of my little section. Jack Ortega, thank you.